The screen is visible to all.
Yes, sir.
Voice is clear. So one can reply in the chat box.
Yes, sir.
Okay. So in the earlier classes, we are discussing about solar geometry angles, like angle of latitude, altitude, and how to measure the different angles by simplifying the main equation, and also some short equations in the last class. Now today we'll discuss about the solar apparent time or solar local standard time. And in the earlier classes, up to that class, we are discussing about the all solar geometry angles. Okay. Now from this class, we'll discuss about the daily measurement of the radiations, monthly average or the monthly measurement of the solar radiations, like global radiation, diffuse radiations, beam radiations, and how we are going to calculate those values. Also the time, if you see, now in the clock, I can tell the time is around 12:05. Okay, as per our timing or the official timing, it is 12:05. But actually, if you measure with respect to sun and the earth movement or the position of the sun with respect to earth, that time we are going to call it as solar time or local apparent time or the local standard time with respect to sun. So that time we are finding, in that time we have to go for some corrections. Why? Because whatever the standard time we are measuring from the clock or from our watches or the mobiles and other things, those are called as the official time of that country. Okay. Now, which are the corrections we have to incorporate to find out the exact location time? That is, for each degree change in the latitude or longitude, which is shown in the below sketch, if you see, for each degree change in that lines, there will be 4-minute difference in the clock. I hope you're understanding. Means, say for example, I will measure the time at Belgaum in one longitudinal location or latitudinal location, and I'll also measure the one more longitudinal location per degree change in that. Say for example, Bijapur or Hubli, maybe on the same longitudinal line. If I measure those timings, there will be changes, 4 minutes change will be there as per the solar path. But as per the clock, throughout India, we are following one time. Okay. So like this, as per the sun, if you see, there will be always change in the timing as per the sun path or the sun movement. And coming to what difference you have to take for that 4 minutes and what difference you have to consider is, for that given location, what is the longitudinal time in degrees, that angle you have to find out, or that will be given for the given location. That is the location longitude. That should be known. And one more is standard time longitude. Means standard time I can write it as 12:05 hours, and standard time longitude is the angle. So that is the standard time longitude with respect to what time is measured. That longitude you are taking, and local longitude. So difference between these two angles, if you take and multiply by 4 minutes, because there is per degree change in the longitude lines or the latitude lines, there will be 4 degree change in the solar path or the clock. If you see, if you compare the solar path and the clock, there will be always 4 minutes change per degree change in the longitudinal angles. So that's why that is plus or minus 4 into difference of longitudes. Last term is plus equation of time correction. So many times this equation of time correction can be given in the problems, or we need to find out by various correlations which are given in the different books. Different books, or in one book, they might have given 2-3 correlations. So in that, this is the one of the correlation which will give us more accurate value of the equation of time correction. So that also depends on the day of that year, on which day we want to find out this solar time or the local apparent time. That day we should know to find the b value, n minus 1, 360 by 365. So once you find out this b value, I can substitute in the equation of time correction. This time correction also varies from 0 to 15 minutes. Okay. So that 0 to 15 minutes, always there will be error. Why? Because the sun path, if you see on the last sketch at the bottom, if you see, in that the sun path exactly on the equinox day is almost 0. There is no difference in the equation of time correction. So like that, if you go for other days in summer or in winter, the sun path will be little bit changing. So that sun path is changing with respect to again longitude and latitude also, because longitude and latitude we have defined it, not the sun and earth. So we have defined those longitude or latitude for our official timings and other follow-ups. But if you go for the sun path exactly, it is not exactly following the longitude or latitude throughout the year. So for that, again, we have to go for the equation of time correction. So that is given here. One of the correlation I will read here. If it is not given, you have to follow up this method, or if it is given, you can substitute directly the equation or the value of that equation. That is 9.87 sin 2b minus 7.53 cos b minus 1.5 sin b. So this is one of the correlation which may give the more nearer value to the local apparent time. So this is all about the solar time. The next we'll see how this equation of time is measured. So for the given month, if you see, or the different months if you see, January to December, the equation of time is shown on the y-axis and the various months are shown on the x-axis. If you exactly see the zero values, so almost it is around 3-4 days it is having the zero value. There is no change in the much of change in the path of the sun. But if you see other months, it is varying from minus 15 near to minus 15 to plus 15. So there will be change in the equation of time in minutes. And one more thing, in the local apparent time, if you see the equation, the standard time we are writing in hours. The second term plus or minus 4, whatever the difference is taken in the bracket, that is in minutes. That much of minutes you have to add or subtract. And addition of equation of time, which is also in minutes. So this is hours and remaining two values are in minutes. Means with respect to that given time from the clock or the standard time, we are adding or subtracting the corrections which is required for the sun time. So this is the meaning of the equation. So next, coming to the important topic, a new topic, estimating the solar radiations. So solar radiation data we have seen, for a given day, we can measure the solar radiations by pyranometer for diffuse radiations or the global radiations. And for the given day, we can go for the pyrheliometer to find the beam radiations for a given day. And also for measuring the sunshine hours, we can go for the sunshine recorder. So these are the three basic equipments we have studied in our syllabus. Still, there are a number of devices we can use it to find the different radiations. So based on those solar data, what is measured per hour or per days, in this topic, we are going to discuss about how these data is taken for the monthly average. Okay, so this monthly average, daily average, or per hour values we need for deciding some equipments to be planted or to be designed on the given location. As per the availability of the solar radiations, we are going to decide. So for this, in these topics, we have various type of radiations. First is global radiation, Then we are discussing about diffuse radiation, how we are finding. Then we are finding beam radiations, how to find out beam radiations, or by the reflection radiations. Different radiations will be there. Our main focus is on global and diffuse radiations. And also you have seen that we have discussed the many solar geometry based on the horizontal surface and the tilted surface. Similarly here also, in the first case, in this case we have taken only horizontal surface. So before starting this discussion, one should keep in mind, here we are assuming the surface is completely horizontal, a flat surface kept below the solar radiations, and we are measuring only global radiations by pyranometer. Only the global radiation is nothing but the total radiation, beam and diffuse. All radiations we are measuring by the pyranometer. That is called as global radiation. So we are measuring daily throughout the month, and at the end of the month we are taking the average. So this they are calling it as monthly average of the daily global radiations on that surface. So one of the researcher Angstrom given this equation. We are not using for the problems, but we need to understand what he explained and later what corrections has been done in this equation. So according to him, he has given the ratio of monthly average of the daily global radiation, Hg bar, that is the average monthly average of global radiations per day, measured per day. Hc bar is the monthly average daily global radiations measured for only for the clear days. When the sun is clear, say for example in September 2 days are clear with sunlight, complete 24 hours or 12 hours sun was shining, and remaining around 10 days were completely cloudy days. So out of that we have to consider 2 days for the clear days, and Hg bar you have to consider all the days of the month. Hg bar. For Hc bar what I'll do, I'll take only those 2 days, I'll take the average. What is the monthly average of those 2 days global radiation on a horizontal surface at the same location on clear days? So that to showcase clear days, he has written Hc, and unit may be kilowatt per meter square day, or it may be kilojoules per meter square day, depends on the given data. Then S bar by S max bar is the ratio of number of sunshine hours. Okay, so earlier in the other equations we were using Ns. So yesterday we have seen this Ns above or in the middle, some equations I have written. The number of sunshine hours for a day can be found out by Ns. That is nothing but S here. That S value they have taken like this. S bar is the monthly average of those sunshine hours what you have measured for a given days. So that is in hours, unit is in hours. And on the same location, again as I told you for the clear days, how we are finding the global days or the global radiations which are maximum. Same thing here in the S max bar. Here also possible maximum sunshine hours. So possible maximum sunshine hours, as I told, for example, I told in September 2 days were clear days as per our assumption. So I can take only those 2 days in which maximum number of hours the sun was completely shining or the sky was completely clear. So only those hours of sunshine we are taking and we are averaging out. That is called as S max bar. And other two constants have been found by different mathematical correlations and also called as constants of the given equation for obtained by some mathematical or data fitting procedures. And here this can be found out and tabulated like this. So one of the researcher Loff has given these tables. In this you can observe he has taken all the values of solar global radiations and found out these AB values for India locations like 17 cities, or above table if you see for the different locations throughout the world. He has shown that S bar by S bar max, what is the values, range, and AB values. So based on their research, they have given those AB values. So that can be given directly in the problem to substitute, or else by referring these tables as a data sheets, we have to substitute in these equations. Now later, a researcher called J.K. Page, what he suggested is, in spite of going for the, especially for the clear days, and finding the average of those clear days is very difficult, because observing the solar radiations continuously each hour or instantaneously and getting the clear day radiations average separately, global radiations average separately, it will be very cumbersome process or the very difficult process. In spite of that, what he suggested is, one can go for the extraterrestrial radiations, which is outside the atmospheric surface, where always the sun is clear and we can get the maximum solar radiations on the external terrestrial surface, and average of that per month can be taken, and this ratio can be considered, that is Hg bar by H naught bar. So that H naught bar is the mean average of extraterrestrial radiations H naught without atmosphere, and it here, for averaging out, what he has done is, he has taken the integration procedure, so integrating all these values over the day lengths and finding for the month. So this equation we are using maximum or more number of time to find the global radiations or Hg bar values. Okay. So any doubts up to here? Okay. Now H naught or the extraterrestrial radiation, how to measure for a given time? Then later we can integrate and you can find out H naught bar, and we can substitute in the main equation or the top equation. So here we need to focus only on the two equations, the above, whatever the, see, tick mark is given to understand which equation we have to use for the calculations, which equations are not preferred for the calculations. So these green color ticked mark what I have shown, these equations we are using for our calculations in the later stage. So below equation, if you see, H naught is 24 by pi solar constant into 1 plus 0.033 cos of 360 n by 365 omega s sin phi sin delta plus cos phi cos delta sin omega s. Now here directly we are using OK, but how we came to this equation is, so as we all know, to find one of the solar constant in extraterrestrial or for the location, we are using this solar constant ISC. So above equation you can see ISC into 1 plus 0.033 cos of 360 n by 365. This equation we have discussed in the earlier classes. Okay, to find the solar radiation. And next multiplication factor is sin phi sin delta cos phi cos delta cos omega. This is nothing but hour angle. So each hour, how much is the radiation? See, first term is radiation term. After integration, hour angle term. So for a given hour, how much is the radiation? That we are going to multiply both, so that we will get the complete day radiations H naught. And in this hour angle cos omega s, earlier you have seen we are writing omega s equal to cos inverse of this sin phi sin delta by cos phi cos delta is nothing but tan delta tan phi omega s. So just recall this equation once again. Omega s equation was written cos inverse of minus tan phi tan delta at the top. Similarly, same equation is also written here. no change. Okay, so as this JK page has suggested to integrate the given values per hour or per day and find out the mean value. So similarly, what they have done is this dt value change in time we are going to integrate. Either you can substitute time value as 180 by 15 omega pi, or you can take omega value itself as in terms of time. So to convert that time in hours to radians, they have taken 180 by pi. I hope that will be clear. To convert hours to radians, one can take for 180 by pi. And omega by 15, earlier we have discussed why 15 is divided, because for the per hour values. And later if you take for the dt, because here dt is there, or dw you can take. So I can write it as dt as 180 by 15 pi dw or d omega. So this if you substitute in the above equation, 180 by 15 is 12, correct? 15 into 12 is 180 value. So that is 12 by pi solar constant into this bracket into integration of, see here what changes they have done. If they have gone for dt, I would have taken t equal to some other values. If they have gone for d omega, they have integrated from minus omega to plus omega, or else you can integrate from minus t to plus t dt. So as in the cos omega value is there here, they have taken integration from omega to omega. So 2 times omega here totally. So once you integrate this value, what you will get? Omega s sin phi sin delta plus cos phi cos delta sin omega s. So this is for the entire day we are measuring, 2 times of the 12 hours, like that, to understand simply. So that will be finally given as h naught equal to 24 by pi. So this is given directly, some books, 24 by pi solar constant into 1 plus 033 cos of 360 n by 365. This everyone knows how to find out the solar radiation. Solar radiation into 24 by pi you have to take into hour angle after integration. So hour angle after integration if you take, that will be omega s into sin phi sin delta sin omega s cos phi cos delta. Okay, so these two equations we are using majority of the time to find out the values of global radiation averages in a given month. And later, to simplify this work, one more scientist called Klein. So Klein suggested, other than finding this h naught value per hour or per day by using this big equation continuously, what he suggested is, for example, in complete summer month, if you take, say for example December, if I consider, or sorry, if I consider February, for complete 1 month, 29 days or 28 days for the February, one can go with the middle of that month. As per his predictions or the observations, one can go for the middle of the month, say for example 14th or 15th day, and he can measure only 1 day solar radiations. And that 1 day solar radiations can itself as taken as monthly average solar radiations. This is the very much time reducing procedure he explained. And also he suggested that if you go for the big months like 31 days or 30 days, in such months you can go for taking the solar radiations not for all days. You can take only the middle of the month, say for example 17th day. I can go for the only 17th day. I can measure entire day solar radiations. That itself I can take it as a monthly average. But some researchers suggested that provided that month should be having all 30 days with the cloudy days, or it should be a clear sun, solar day or the clear sun days. In such months, one can go for the middle of the month and he can find out 1 day of the radiations, and that can directly considered as monthly average. So that is suggested by the Klein. That also can be done. But here, that all depends on the measurement of that day also. So one can go with the instrument, he can measure, or by this again equation you have to come back to compare those measurements whether this equation will measure correctly or not. So these equations also predicted nearly the same radiations with very less percentage of error. So by equation means you can go by this equation to measure the average solar radiations for the given location. Okay. Any discussions at this point? There may be one question that why we have to go for extraterrestrial radiation, why not surface radiations on the earth? So for that you can just observe this concept, that is air mass concept. This air mass is whatever the atmosphere covered by the earth, that is called as air mass, or the atmosphere itself you can call it as air mass. The difference between atmosphere is containing all the gases and other things that we know. Air mass, why it is called as, here we are taking some ratio. That ratio is between, you can see the sketch here, the solar radiations are coming in the direction of C to A, and at A point the solar radiations are hitting on the earth surface, and B to A is zenith, or the at 12 noon the solar radiations are passing from the B in line with the zenith line, and with very less atmospheric disturbance the solar radiations are falling on earth at A point. So what is the required thing here is, one can find out how much is the disturbance from the atmosphere is taking place for the given angle of the sun radiation. So if you see at 60 degree, if you consider solar radiations as per the 1 by cos theta relation, or I can take a ratio of AC by AB. Okay, at 60 degree, if you see the solar earth air mass is 2, means there is more loss in the solar radiation. Why? Because once the solar radiation enters the earth's surface, it is going to be absorbed by different pollutants, dust or water molecules, clouds, or scattering may be possible. Due to this, what will happen at point A on the earth's surface, the available radiations will be very less, and measurement of these all absorption and continuous change in the radiation, it is very difficult also. Continuous you have to observe all the radiations, how they are changing, what data we are collecting. Okay, so these all will take a lot of time and very cumbersome. So to reduce all these things, what JK Page is suggested is directly go for the extraterrestrial radiations and find the solar radiation values, so that disturbance will be less. Directly you can take the solar constant and some corrections for the given day. So finding this H0 value will be very easy for everyone, like that. Or in the other sketch you can see here, air mass when it is 1 means it is passing very less or minimum distance in the atmosphere, so that losses will be very less. But if you see the bottom line, atmosphere, where the solar radiations are just passing through the atmosphere, not reaching the earth surface, that may be also possible. If you go for the other one, 1.5, there, assuming one horizontal surface on the earth surface, if you take the normal to that horizontal surface like CA line, and if you take the ratio of that larger distance traversed by the solar radiations, and if you take the ratio with that larger line to the smaller depth of atmosphere, one can find out the air mass. So to overcome this air mass difficulties, J.K. Page has suggested to go for the directly measuring the extraterrestrial radiations. And one more difficulty what researchers also found is different countries have different air mass values. Because here we are just finding by the ratios. But actually if you go by absorption of the solar radiations and actual quantity of solar radiation what is measured on the earth surface, if you find out, for different countries it is different. The countries like China or India it is very less because pollution is more. Then density of the atmosphere may be changing continuously every year. But it is very less for some other countries which are having less pollution or full year there is a continuous sunlight, it may be different. So like this, the air mass or the equations based on this correlation, if you say clear day or cloudy day, if you go on finding like this, it will be very difficult for different locations and different countries. But in this situation, if you see, going by this equation, it will change very less with respect to different countries. This H naught equal to 24 by ISC, what we are finding, this will be changing very less. Okay. And also one of the researcher Gopinathan also given different correlation. What he suggested is, in spite of going this with A plus B as a constants, he suggested these correlations. For A1, you go by this correlation and find A1 constant. For B1, you go by these correlations and find out B1 constant. But here difficulty is what? Remembering these all decimal points, 5 value should be known for A and B. Also, EL denotes the elevation of the position or elevation of the location. Means, if I take the location as Belgaum, we should know, or the data should be given that what is the elevation or what is the height of the Belgaum from the sea level. Then I can find out the solar radiation, how much global radiation is received on the Belgaum by using A1 and B1. So if you can remember, you can go by this Gopinathan correlations, or directly you can go by using those AB constants from the given locations, these values. Or these values can be given directly in the problem itself to directly substitute and get the results. Is any discussions? Am I audible? Any doubts here? These are just all correlations. If you want to understand these correlations, you have to buy those research papers. Okay. Okay. So in this, you can also understand what are the values they have found out for different angle of the solar rays with respect to the zenith. So for the extraterrestrial radiation, as I can tell you, air mass, when the solar rays are not passing to the atmosphere, I can consider that air mass as zero. So when air mass is zero, or there is a vacuum, or there is no atmosphere itself in the extraterrestrial surfaces, there I can consider it as maximum solar radiation which is received above the earth's surface or the earth's atmosphere. That they have given around 1376 and we are taking 1353, whatever. So that is the maximum radiation available above the atmospheric surface in watt per meter square. But coming to the air mass 1, if you see, when sun is exactly aligned with the normal line to the horizontal, see the solar radiation. It is reduced from the solar constant. How much it is reduced? It is reduced up to 1105, around 1000. Still, if solar radiations inclined to the earth's surface from the normal line, around 48 degrees if you consider the solar rays to the surface, or air mass as 1.5, the solar radiations are around 1000 watt per meter square. And still, in the evening time or the morning time, if you see, air mass is around 2, and at 60 degree of the solar rays are coming and hitting on the horizontal surface. See the solar flux or the solar radiation on that area. It is still reducing up to 894. Like this, solar radiation is go on reducing depending upon the atmosphere or the air mass. So these all difficulties to keep all these tracing of the points and tracing of the readings, how they are reducing or how they are increasing, is very difficult. So for such cases, better to go for the extraterrestrial radiations where the solar constant can be used, and with some small corrections we can come to the solar actual radiations which are taking place above the atmosphere. Then with the hour angle or the correlations given by the different constants, one can find out the solar global radiations for the given month easily. So today I think we'll stop up to this global radiations. Tomorrow we'll take monthly average diffuse radiations. So like this we are discussing on diffuse radiations, global radiations. Then we are discussing about beam radiations with various correlations. So there are for each topic they have given 2-3 correlations. In that, which correlation will be better for using the problems we'll discuss. And later, after completing these all correlations, again we have to discuss on tilted surfaces, the surfaces which are inclined to the horizontal. That is again one of the other part with the same repetition, but the correlations will be different for tilted surfaces. Okay, sir, could you please share soft copy of the textbook and PPT? See, soft copy of the textbook I have shared from Flatmate Collector with this one. Still, it is not available online. If anyone could come to the library, anyone localite can come to the library and take one of the book like G.D. Rai or Sukatme, and if he can circulate to others also, it is very good. That is one thing. And directly scanning and sharing will be difficult for us also. PPT I can share. PPT no issue. We can prepare daily wise and you can share it. But about the book, it is very difficult as far as this time is concerned. And one more difficulty is this is the first time floated in the college. The subject is floated first time in the college. And also, I found out many colleges, the solar subject is handled by staff is very less outside. Or even I request everyone to find the solar subject in other colleges earlier, either in VTU or autonomous, in which college the subject is floated. If you could find out that also, we can interact with them. Or you can find out some more books which are soft copy in the form of soft copy, or any other good books which are available from their side. You can also find out. Okay. One main thing here in the subject is maximum is the correlations and the equations they have given. These correlations and empirically is just their assumptions or depending upon their work, they have given the equations. And some of the equations we can give the proof why it is coming like that, why it is derived like that, something we can correlate or give some relations. But for the empirical relations, it is very difficult. Because in the books they have given directly the empirical relations, without going background and different studies. Or if you want to study that also, you can refer the pages or that research papers you have to refer. That is one of the difficulty. So that's why you have to write down all the equations in a systematic way with the proper titles and remember all these equations for the calculations. Are correlation important for the syllabus? Yes. The correlations which I have tick marked here to be used in the examples, for example, like this, which are tick marked. These green color tick marks you have to remember, or you can write it separately, which are used for the calculations, which will give us more near values with respect to the actual measurements. And the correlations which are marked with the red color cross mark, those can be skipped because those are giving the values, but percentage of error with respect to actual measurement is more. That error is more. So I have shown in the cross mark like this. Okay, so tick mark correlations you can refer, you can note down and remember. Like that, I have made some changes in the PPT with tick mark and with cross mark. So like this also is not important, but using this correlation will be very useful for all. Okay, last any other points? In syllabus, they have mentioned solar radiations measurement and numerical examples. So we need to study. Okay, I think we'll stop the class here. It's exactly 12:45 now. Next class we'll take the diffuse radiations and the tilted surface radiation correlations. Then later we'll take the numericals from solar geometry to the solar radiation monthly average values. Thank you.